Hello students, in this video we will discuss chapter 5 part B numericals of 9th standard physics. In first numerical, density of copper is given 8.83 gram per centimeter cube, density of copper in kilogram per meter cube. For that simply we have to multiply this numerical value with 1000, so we'll get the answer. Density of copper is 8830 kilogram per meter cube. Second one, relative density is given 13.6. We have to find density of the substance in CGS. Formula is relative density, density of substance over density of water in same system of unit, that CGS we are taking. So density of substance is equal to 13.6 and density of water in CGS is 1 gram per centimeter cube. So in CGS you can take. So density of the substance will become 13.6 gram per centimeter cube. In kilogram per meter cube, simply this value you can multiply with 1000. So answer is 13,600 kilogram per meter cube. In third numerical, density of iron is 7.8 into 10 raised to 3 kilogram per meter cube, and relative density is equal to 7.8 into 10 raised to 3 kilogram per meter cube divided by 1000 kilogram per meter cube. So now these two units will cancel out and relative density answer is 7.8. So here I am writing it. Now fourth one is easy one, you can do yourself. I am leaving it. Fifth one, volume is given 2 meter cube. Relative density is equal to relative density is 0.52. So relative density of substance over density of water. Density we can write as mass over volume, and density of water is 1000 kilogram per meter cube. So mass by rearranging we can get 0.52 into 1000 into 2. So answer is 1040 kilogram. Sixth one, volume is 4.5, 3.5 into 2.5, product of this. Density is equal to 1.3 kilogram per meter cube. Mass over volume is equal to density. So mass again we can get by multiplying density into volume. So simply you can multiply, the answer will be approximately equal to 51.19 kg. In seventh numerical, mass is 113 gram. Difference in the water level 40 milliliter minus 30 ml. So answer is 10 ml. Relative density, that is equal to density. So 113 gram mass per unit volume, that is 10 centimeter cube, because 1 ml is equal to 1 centimeter cube. Here I am written. So density of the water is 1 gram per centimeter cube. If you solve, relative density is equal to 11.3. Eighth numerical, volume is 100 centimeter cube. Actual weight is 1 kgf. Apparent weight is actual weight minus upthrust, 1 kgf minus 100 centimeter cube, V rho g. Density of water is 1 gram per centimeter cube into g. So 1000 gram force minus 100 gram force, 900 gram force. This is the apparent weight of the body in water. B part, relative density is equal to density of substance over density of water. So density of substance, that is 1000 gram, and density of water, that is equal to 1 gram per centimeter cube. So 1000 gram over 1000 centimeter cube, answer is 10. That is for relative density. 10th numerical, actual weight in air is 120 gram force, apparent weight is 105 gram force, loss in weight, that is equal to upthrust 15 gram force, relative density is equal to mass of body over mass of displaced water. So 120 gram divided by 15 gram. So if you solve, you will get relative density equal to 8. Ninth numerical, mass 70 kg, weight is 70 kgf in air. Volume of displaced water, that is 20,000 centimeter cube. If you will convert into meter cube, that is 2 into 10 to the power minus 2 meter cube. Upthrust, that is 2 into 10 to the power minus 2 V rho g. Density of water 1000 kilogram per meter cube into g. Fv is equal to 20 kgf. Apparent weight is actual weight minus upthrust 70 kgf minus 20 kgf 50 kgf. That is apparent weight. Second part, relative density is equal to actual weight in water divided by upthrust or loss in weight. 70 kgf divided by loss in weight. So 70 kgf divided by 20 kgf. So relative density is equal to 3.5. In 11th numerical, actual weight is equal to 32 gram force. Apparent weight in water is 28.8 gram force. First part, volume of solid we have to find. So loss in weight is 32 gram force minus 28.8 gram force. Upthrust is 3.2 gram force. Now upthrust is equal to V rho G. 3.2 gram force is equal to volume into 1 gram per centimeter cube into gravity. So volume will be equal to 3.2 centimeter cube from above relation. Second is relative density. So actual weight minus loss in weight. Actual weight is 32 gram force. Upthrust is 3.2 gram force. Relative density is 10. Third part, relative density is equal to W1 minus W2 over W1 minus W3. One of the liquid is given. So relative density of that liquid is 0.9. 32 minus W2 that we have to find. 32 minus 28.8 gram force. If we will solve this, 32 minus W2, this will remain over here, and this you can multiply 0.9 into 3.2. So W2 is equal to 32 gram force minus 2.88 gram force. Answer is W2 equal to 29.12 gram force. 12th numerical, relative density is equal to W1 over W1 minus W2. Actual weight in air is 20 gram force, and W2 is the weight of the body in water. So 20 gram force minus 18 gram force. 20 gram force divided by 2 gram force. Answer is 10. Relative density is equal to 10. 13. In 13th numerical, relative density of solid, that is equal to W1 over W1 minus W3 into relative density of liquid. So relative density of solid, that is 1.5 divided by 1.5 minus 0.9 into 1.2 into 10 to the power 3 divided by 10 to the power 3. So if you'll solve, you'll get relative density of solid equal to 3. In 14th numerical, relative density of pure gold is given, that is 19.3. Actual weight of the ornaments, that is 25.25 gram force. Apparent weight in water is 23.075 gram force. So relative density of gold ornaments, that is equal to 25.2 gram force divided by 25.25 minus 23.075 gram force. Now after solving, you'll get 25.25 divided by 2.175 gram force will cancel out. Answer is 11.6, which is quite less than the density of pure gold. So relative density of gold of ornaments is 11.6, which is quite less than relative density of pure gold, that is 19.3. So it means this is impure gold. 15th, W1 is equal to 14.5 gram force. Density of iron is 8.9 into 10 to the power 3 kilogram per meter cube. W2 you have to find. Apply the formula relative density is equal to W1 over W1 minus W2. Now rearrange it. W1 minus W2 you can bring to this side. So W1 over relative density. W1 minus W2, because W2 you want to find, so take it to this side, and W1 over relative density you can bring to this side. Substitute the formula. 44.5 minus 44.5 over 8.9. So it is in gram force is equal to W2, that is the weight of iron in water. So 44.5 minus 5 gram force, it is 39.5 gram force is equal to W2, which is the weight of the iron in water. Now 16th numerical, weight of the stone in air is given. W1 is equal to 15.1 gram force. Loss in weight of the stone in water, that is 15.1 gram force minus 9.7 gram force. So FB, that is the loss in weight of the body in water. So W1 minus W2, 5.4 gram force. Now out of this we can get volume, because buoyant force formula is V rho G, that is 5.4 gram into gravity. So volume is equal to 5.4 gram. Density of water is, that is 1 gram per centimeter cube. So after solving, you'll get 5.4 centimeter cube, that is the volume of that body, that is equal to 5.4 centimeter cube. Third part is relative density. So W1 over W1 minus W2. So 15.1 gram force, that is the weight in air upon loss in weight in water. 5.4 gram force. After solving, you'll get relative density equal to 2.79, approximately 2.8. Fourth part, relative density of the liquid, that is equal to W1 minus W2, where W2 is the weight in liquid, W1 is the weight in air, W1 again weight in air, minus W2, that is weight in water.
So 15.1 gram force weight in air minus 10.9 gram force weight in liquid, 15.1 gram force minus 9.7 gram force, this is the weight in water. If you'll solve this, you'll get approximately relative density equal to 0.78. After solving, you will get 0.777. So here it is 0.78 without any unit. So you can watch this video again and again and practice at home in return. Thank you.